Good to start. So let's start. So any question on type 2? Okay. So let's move further, right? So why we have to send IP, basically MAC and ARP information separately. I think it's clear to everyone. So next is ARP separation, right? So basically, if we think, right, basically, let's say this server 1 MAC 1 is connected to this VTAP, right, on ET1. As soon as server communicates to any of the device in the network or to the gateway, we will learn locally MAC address as well as ARP, right? So we learn MAC and ARP, right, locally. As soon as we learn the MAC address and ARP for that VLAN, right, we'll create type 2 EVPN route, right? Type 2 EVPN route that is only for MAC and also MAC plus IP, both, right? ARP and MAC, and advertise it to via BGP or basically BGP EVPN or MPBGP, right? We will also add sequence number. Okay, we'll see why we need to add sequence number, but that is not in each and every case, right? That depends on so we will discuss when we'll add sequence number, but that is optional if required, right? Similarly, as soon as server to MAC to communicates, we learn, again MAC and ARP locally here, and that will also create MAC and IP type 2 route, and it will also advertise to all other VTAPs, right, through BGP EVPN. So the advantage of this is that you are suppressing ARP, right? Because as soon as this guy has communicated, you are already sending that ARP information to all the other VTAPs. So all the other VTAPs, right, in the network do know that what is the ARP for this server 1, right? So basically, when this this host behind any other VTAP wants to communicate with this server 1, they don't have to now send ARP requests, right? So unnecessary ARP flooding as well as ARP reply, right? That all will be basically suppressed, right? So that's why, that's the reason with EVPN, right? We are able to suppress ARP at most of them, right? Because as soon as once this local device learns the ARP, it will advertise it to everyone, right? So it's just a matter of time that that local device communicate with any other device or through the gateway. Once ARP MAC is learned, it will be advertised. Okay. Any question?
Hey, Vishal, not related to the slide, but we're recording this session.
Yeah. We are.
Okay, awesome.
Yeah.
I think the others are on another call, so that's.
Oh, no problem.
Yeah.
Yeah. Yeah. Okay. So this is the one, right? Let me first clear this out. Yeah. So yeah, this is the one, right? Where we so this is the one where we will send that sequence number. Okay, and we'll see in next slides how, where, in which case we need to send that. Okay, so okay, so now next is MAC mobility, right? So basically, let's say we have this particular host, right? This host is connected to one particular, this VTAP 1, and it has learned the MAC address, right, locally on ET1. Now next what we will do is we'll generate type 2 EVPN route, right, for that MAC with sequence number 0, because this is first time, right? As soon as MAC is learned, we generate type 2 route for MAC and send that out. There is no sequence number field added here. Okay, so if you see here information, we have MAC address, correct? RD, route distinguisher, right? Route target, correct? VNI, which is nothing but VLAN to VNI mapping, tunnel encapsulation, right? Tunnel type, it is VXLAN. So data plane we are going to use is VXLAN. So tunnel encapsulation is VXLAN. And Ethernet segment identifier is all 0, right? Can anyone tell me why it's 0? ESI?
Because it's not dual home.
Not dual home, and even though, see, it is a dual home, right? This is, let's say there is MLAG pair and this is dual home. But if this is a MLAG, right, then we don't need to send this ESI, right? Because that's not needed.
Yeah,
We'll discuss.
yeah.
Yes. So yeah. So because basically we can say not multi-home, right?
Yeah,
The multi-home scenario what we have seen. Okay, yeah. So basically it will send out this type 2 update, right? Message to VTEP2. Okay. Now let's say we do vMotion, right? We perform vMotion and move that host from VTEP1 to VTEP2. What will happen? This MAC will be learned here, right? And then what it will do is it will send out.
GAR.
Sorry.
The host should send out the GARP, right?
Yeah, means a host can send out GAP. Yeah, that's right. That's, but okay. So yeah. So as soon as this guy move, that depends on server, right? Whether it sends out GARP or not. But basically, as soon as this server host communicates with any other device or the gateway, we learn the local MAC here, right? As soon as we learn the local MAC here, what we'll do is this guy VTEP2 will send out EVPN type 2 route, right? For MAC, like, which is nothing but MAC address and RD and all that information, right? But now there is, let's say, one more VTEP3. Okay. There is VTEP3. So initially host was under VTEP1. Host was under VTEP1 and it has sent out type 2 address, right? Type 2 route, MAC. So VTEP3 has updated MAC address table and VXLAN address table, that this for host H1, right? Host H1, the destination is behind VTEP1, right? Behind VTEP1 based on first update. Okay, first update when host was behind VTEP1. Now you move this host, right? You move this host from VTEP1 to under VTEP2. Okay. Now VTEP2 will send the advertisement that, hey, this host is local to me, right? It will first update its own MAC address table. So here also, if you see, initially MAC address table was that H1 is behind VTEP1, right? MAC and VXLAN address table. It was behind V1. But as soon as it learns locally, it will update that now it is behind ET2, right? ET2. Okay. And as soon as it learns this, it will send out EVPN type 2 route, right? Now, when this route information reaches to VTEP3, it will check the sequence number. So initially sequence number was not there, right? Not there means it was 0, right? When this guy has sent the update message, right? It was 0 sequence number. But when the whole VTEP3 now receives sequence number as incremented, right? 1, it will remove this V1. Basically, it will consider this type 2 route as a new updated one, and it will change it to V2, right? Similarly, when this route received by here by VTEP1, right, it will also update its routing, basically MAC table, and then it will change H1 to VTEP2 instead of previously it was locally learned, right? So that's where this sequence number field comes into place, and that will be added like this. It will be here this way. Okay. And also it will be in packet capture, right? And in command, you can see here that it is 1, sending a sequence number 1. Okay. Any question?
Vishal, so how does basically VTEP2 know that I have to generate it with sequence number 1? Is it because the MAC address was learned on VX1 first?
Yes. So basically, because VTEP2 knows right, that it has already learned on VX1, and in fact he has that EVPN route, right? BGP EVPN route it has, right? So basically it knows that, hey, there is already one route has already come, right, which is pointing to VTEP1. So when I have to initiate one, right, it will initiate with updated sequence number.
Okay. But so in case suppose there is generally genuine MAC flapping, right? Because of some loop or something.
Correct.
So how does it handle that then?
Right. That's a good question. So basically what happens, right? Let me just remove this part so that we have space to, okay. Yes. Now in case of MAC flap, right? Generally, let's say there is a loop between this, right? Under this, and it is on flapping. So what will happen? Initially, this guy will send that, hey, I have this locally learned. As soon as this guy also send some packet here, this will also increment and sequence number and send all the VTEPs that, hey, I am the one, right? I have this MAC, right? Learn. And this keep on happening. And this is unnecessary. Basically, you are sending a lot of EVPN route updates continuously, right? And that can create a big problem, right? Into the network, right? So basically what we do is, right, we have feature. So as soon as there are MAC flap and basically there will be threshold. I don't exactly remember what it is, but basically we will put that MAC address in blacklist. So once we see that particular MAC is flapping continuously in EVPN, we put that MAC into blacklist. Okay. So basically we will stop learning the MAC. We'll put it in a blacklist, and it will you can see that in our log messages that particular MAC has flapped and it is blacklisted. Okay. So basically what we have to do is we have to go and clear the MAC address, right? Clear that blacklist. There is a command. So we have to just clear that out. And after that, again, it will start working. But again, if it sees that MAC is flapping, it will blacklist it. So this is basically protecting EVPN route, updates, massive updates, by blacklisting it. This is same as in with BGP, we have route dampening, right? Like of feature. So it's in this, we have blacklist where we stop learning MAC addresses so that unnecessary route updates will be stopped. Okay. And so we have seen a lot of cases, right, where customer is facing intermittent traffic issue and all that, or flooding of traffic, right? Because now MAC is not learned, so whatever traffic for that MAC, right, that will be flooded, right? So we have seen, and during in that case, we can check if that is MAC is not blacklisted, right? So yeah, that is one. That is how we can prevent this. Okay.
Vishal, I have a query.
Yeah.
So the sequence number is primarily to get the latest updated MAC address
Yes.
during the MAC aging timeout. Is it so?
Not MAC aging timeout. It is during MAC learning timeout, right? As soon as you learn MAC, you advertise that type 2 route with sequence number 1. Add it.
Okay, an update message will be sent from VTAP 2 towards all the VTAPs.
Yes, VTAP 2 will send to all the VTAPs. Basically, it's a EVPN neighborship. So VTAP 2 has EVPN neighborship to spine, and spine has with all other VTAPs. So that way it will reach to all the VTAPs.
Okay.
Okay. Yeah. Any other question? Yeah, go ahead.
My question was that when we are moving the host from VTAP 1 to VTAP 2, right? So now since the host is not on VTAP 1, is VTAP 1 gonna send like a withdraw a message, and in case of that withdraw message, like the withdraw route is sent, will VTEP 2 now remove the MAC address, and since now the host is again added on VTEP 2, will it be still sending the type 2 route with sequence number 1?
Okay,
Since it
yeah,
had like removed the
okay, yeah,
because of the
I
withdraw
got
message.
your question, and that's very good question, right? See, what you mean is whether this withdraw route will be sent, right? As soon as H1 moves here,
Yeah,
right, from one
yeah.
location to another, whether VTEP 1 will send out withdraw message and then VTEP 2 will flush out that MAC table, or other VTEPs, right? VTEP 3, let's say this is VTEP 3, will flush out that MAC. Okay, so let's understand, right? When we will send, okay, so let's say H1 has learned MAC address is learned here, right?
Yeah.
When we will withdraw the route, when we will send type 2 route for withdraw MAC address.
When it's removed from the MAC table.
Yes, when it is removed from the MAC table, right? Now, when MAC table will remove this MAC address, what are the possibilities that it has to remove the MAC address?
Either it ages out.
Aging time, right? Age out.
Yeah.
Okay. So maybe it can be 5 minutes, which is default, or if we have increased it to 4 hours, right? Or less than small 4 hours to make it similar to R, right? Whatever it is. So it's a one is aging. What else? Is there any other way it will flush out MAC or clear the MAC address?
I think
The link goes down.
I'm sorry. Link goes down, right?
Yeah, yeah.
Yeah, link goes down, right? Then also you will remove this, right? Okay. What else? Or STP churn, basically, right? Basically STP update and we clear flush MAC or something related to, yeah. So these are the few possibility. Now let's say this link is connected to ESXi server, right? This is a big ESXi server where all VMs are there. Along with that VM, you have this H1 host is also there. Now you are just moving this H1 host, right, to another ESXi server, right? Here under this. This is one VM out of many. So do you think this link will go down in that case? This is ESXi host. You are moving just one VM. There are many VM hosts,
Yeah.
right? So this link will not go down, right?
Yeah.
Mhm.
Yeah.
So basically this MAC will not flush out because of H1. Basically link is up. So because of link down, this MAC will not flush. Now let's say you are moving H1 to here. What do you think? This MAC will be there or it will flush out as soon as you move H1 to here?
I think it will be there, and it should flush out when it receives a type 2 route with the updated sequence number.
Yes. So yes. So you are right. So one is there are two possibilities, right? Let's say H1 has moved out here, but obviously your MAC will still there because link is up, still up, and aging time is not expired, right? Aging time is not expired. Basically, it says not age out. So it will keep here, right? Now, if this host is already moved here, it does not send GARP, right? It does not communicate with any other. Then what will happen? Eventually, this timeouts, MAC timeouts, and it will flush out, right? And then it will send out a withdraw message to all the VTAPs, right? So that is one possibility, right? In case host is moved, but this guy has not sent any packet out, right? It is ideally sitting. So in that case, this MAC eventually will age out after aging time period, and it will send out the withdraw route. But in most of the cases, as soon as you move this H1 to H here, right, it start talking, right? Sends GARP or sends any packet to any other device. In that case, what we discussed, right, that MAC is still here, right, can locally learn. Now this guy will learn local MAC address, send out type 2 update with the updated sequence number. And as soon as you receive this type 2 with updated sequence number, you will remove the previous ET1, right? ET1 with this VTAP2 update, information, right? Correct. So yeah, so depending on the scenario or situation, either we send out withdraw VTAP1 or we receive update message from other VTAP and we change the MAC address table, right? Is it clear?
Yeah, Vishal. So in the scenario when VTAP one is sends out a withdrawal message, then VTAP two. So now when finally the host starts communicating using GARP or any other packet, then VTAP two will now send out a type 2 route with sequence number 0, right? Or
yes.
because
Okay.
now the MAC
So
has been flushed out.
yes. So see, basically, if this MAC is flushed out due to aging, right?
Yeah.
And it has sent out withdraw. Now VTAP2 has withdrawn that route, right? For MAC H1. It does not have, basically there is no MAC learned for H1, right? Because this guy also has not started talking till now.
Correct. Yeah.
So there is no MAC learn. Now, as soon as this guy starts talking, right, it will learn MAC H1 locally, right? On whatever ET2, right? ET2. Then it will send out with sequence number 0 because here also MAC is flushed. Nobody knows about H1, right?
Correct.
During that time. So it should be sequence number 0.
Okay.
Okay.
Yeah.
Vishal, so this tracking of sequence number in each device is which I see there is a table which has been tracked on. Is it the VI stand MAC address table or the BGP RIB just storing the sequence?
Yeah. So actually, okay. So see, we will not be able to see in MAC address table or anywhere, right, about the sequence number. Obviously, we can check show BGP EVPN detail command output, right, which will give us. So see, basically, see this. So basically, as soon as, you know, let's say it was initially VTAP2 has initially learned it through VTAP1, right? VTAP1 this MAC. And then you locally learn that. So basically what you will do is you will locally generate this MAC address, right? And as soon as you locally generate MAC address, you will also generate sequence number, right? Because you know that there is a already MAC and eBGP route, EVPN route already present for this MAC, right? So I have to send it with updated sequence number, right? Now that information somewhere, basically now how it will basically which agent takes care of it, I don't know. Okay, most probably it will be BGP VPN agent, BGP table, right? BGP agent which might be taking care of it, or MAC agent, right? But I don't know exactly which agent is taking care to send with sequence number 1, 2, whatever, right? Or 0, I don't know. But definitely, basically this switch will take care of it. And show MAC table will not reflect what is the sequence number, but yeah, we definitely can see. So basically, when we run show BGP EVPN table detail, right, it will show right now because it is showing because it has received from another VTAP. It's showing like this, but otherwise it shows as local, right? Locally generated route. So in that case, you would be able to see, you know, this MAC mobility. So it will generate as soon as it learns and local route with this sequence number, and then it will send that out.
Yeah, thanks, Sean.
Okay. Okay. Any other questions?
Vishal, so here, suppose we don't have sequence number, right? Even in that case, we'll move the MAC based on the EVPN route that we are receiving, right? Even if we do not have a sequence number, or for some reason one of the VTAPs is sending with the same sequence number. Like I want to understand that functionality of sequence number. Is it for EVPN to know that this MAC is moved a few times, or is it just for the VTEPs to move the MAC within their MAC address tables?
Okay, so I think, yeah, so see, one is again sequence number. One reason for it is that it also tells you that MAC has moved, right? Initially you would have learned that through another VTEP, for let's say VTEP 3. As soon as it receives with sequence number, it will basically say that, hey, this MAC has now moved, right? Initially you have learned it through VTEP 1, but now it is some another VTEP, right? So basically, and also it sends the updated message, right? That, hey, this is the latest message. You consider this instead of the old one. So basically, let's say one thing, right? Let's say this MAC is flapping continuously, right? What will happen now? VTEP 2 will send the update message to VTEP 3. VTEP 1 will also send update message to VTEP, right? With sequence number, it's their own sequence number. So now which one it will consider, right? Let's say it has come almost same time or whatever, right? Then based on sequence number, higher sequence number, it will select that particular, right? So that can be one, yeah, is one reason, right? Why we need sequence number.
Okay, and okay, understood.
Yeah. Okay, any other question? But yeah, that's good that you have asked, this question so that we can discuss different possibilities. Any other question? Okay, so let's move to next. So that's all what about MAC mobility and MAC type 2 route. Okay. Do you guys have any question, or if you want to see, I can show you in lab. If config, okay, let me. So this is host to host. This is host 1 and host 2, and these are leaf 1A, and this is leaf 2A. So this is 1A 1B is pair, 2A 2B is pair. Okay. And yeah, this is host 1 and 2, and IP address 10.1.10.101, and this side is 11.102, right? So let's ping sudo ping 10.1.11.102. Okay. So I started communication from this host, right? So let's check what is the MAC address of this E9A0, right? So let's check here MAC address table. MAC address table E908, right? In VLAN 110 that has learned locally, correct? 14 seconds ago. Okay. So this has learned, right? MAC has learned locally for this. Now what we'll do, we'll generate, and we can check ARP also. So show ARP, right? 10.1.10.101. This is locally ARP also generated, right? So locally ARP is generated, locally MAC is generated, right? So now let's check show BGP EVPN detail, right? That will show us all the EVPN routes, correct? But if I want to check only type 2 route, right? This will have type 3 route and all other routes, right? If it is there. So there is command show BGP EVPN route type, right? Which route type I want to check, right? So I want to check MAC IP, which is type 2. Here it also says type 2, right? So I want to check MAC IP route, type 2 route, right? Even I can give particular route IP address to I want to check, or specific particular. But here, let's say detail. I want to check it in detail, right? So this is the one. Okay. Now let's see. So what is the MAC address? E90A, right? We are looking into for the MAC address of E90A, which is this. See, BGP routing table entry for this. Okay, let me make it big. Okay. Yes. So BGP routing entry for E90A, right? Route distinguisher. This is the route distinguisher we have configured, right? For this MAC RD, correct? Then see, it has originally generated. So as soon as you learn the MAC address, right? As soon as you learn this MAC address, it has generated this type 2 route, right? Locally, right? And then you can see this is the route target, right? Ethernet segment identifier is 0, all 0, VNI is 10110, and tunnel type is VXLAN, right? How we know? Show run int VXLAN1, right? So for VLAN 110, VNI is 10110, right? And show run sec BGP, right? So VLAN 110, we have RD this 10110 and RT also 10110, right? So that's what here we can see that RD is 10110 and 10110. This is the router, right? So it has generated local route, right, for MAC address. Similarly, as soon as you learn the ARP, right, show ARP, this ARP, it will also generate type 2 ARP update, right? MAC plus IP, that is called MAC plus IP. So this is the MAC address and this is the IP address, combination of this MAC IP update, right? With same all other information I have same RD, route distinguisher, route target, locally generated, right? And VNI and VXLAN encapsulation, right? Is it clear? So as soon as you learn the MAC, right, you will generate local route. Then what we'll do? Then we will advertise this, right, to the towards the spine. So we have this guy has two spine connectivity, right? So neighborship EVPN neighborship show BGP EVPN summary, right? So I have EVPN neighborship with both the spines, right? So let's check show BGP EVPN, right? Neighbor one, right? Yeah, just a minute. This show BGP, I think then neighbor and EVPN. One EVPN advertise route, right? So basically this two routes, right? E9, this two, right? We are advertising to the spine, correct? So we are advertising this route to the spine, okay? Spine 1 and 2, both. So we'll advertise this. We can check detail as well in case we want to check the detail output, right? So let's find out where it is. Yeah, this one, right? E09A. So basically it's saying that, you know, we have generated this route locally and this through this AS. This is the AS number, local AS number, and originating, right, 254.3 this, and we are sending this route update for MAC and ARP. Okay, is it clear? Any question? And then the same route we will receive here through that spine. So that spine will receive this update. It will not install in anywhere in that its routing table. It will just forward it to another side leaf 2, right? And as we can see here, same route, right? We have received here. So okay, let's check show BGP EVPN route type MAC IP detail, right? To avoid all the other unnecessary. What happened? Show BGP EVPN route type MAC IP detail. BGP EVPN detail it's showing. I don't know why that's a problem. Okay, let me ping. I think maybe we don't have route. Let's ping again, right? Maybe that is flushed out. Yeah. Okay, yeah. Okay, so E9A0, right? So that was E9A0. Where is that? Are we seeing this?
It's not.
Last one, I think.
Yeah.
Yeah.
This one. Okay, so E9, yeah, this is the ARP update, right? What we have received, correct? So we have received from the EVPN neighbor VTAP IP address. This is spine IP address, right? This is spine. This is VTAP IP address and this information, right? Yeah. So this is how it will be advertising. Okay. Any question? Okay. So now let's move to type 3, right? IMET route, inclusive multicast route. This is nothing but to populate our flood list, right? Flood list population, so that any bump traffic comes to the VTAP, it will refer the flood list to send that traffic, unknown multicast, unknown unicast, multicast, or broadcast like app request to all the other VTAPs, right? Because it doesn't know under which VTAP the destination MAC basically host is, for which it has to send out the app request, right? So it has to, we have to flood that out to all the VTAPs, and that information of other VTAPs for that VLAN will be populated automatically through type 3 update instead of hidden replication, right? What we used to do is basically manually configure that, but now it will be automatically updated, right? Against. So yeah, so this is the format, right? Basically format of this, right? Field of this type 3 update. As we know, this basic is already there, right? With all the basically this is common, right? And then inclusive multicast route, these are the new update. These are the fields like type 2 had, right? So one is, let me just quickly open the capture, right? Yes, so let's BGP, right? Okay, and update message, right? This update message, and let's check. So if you see here, right? See, this is a withdraw route. Okay. Let me see if we want to see the update message. Wow, this are lot many. Let's check this. Okay. So this packet. So if you see here, right? See, this is the TCP, and over that Ethernet frame, IP protocol, TCP, right? TCP header, and then we have BGP. If you see here, there are 4 update message. We can combine as same as BGP. We can combine multiple update messages into single one, right? Single message what we send. So there are 4 update messages. Let's check one by one. What are they? That messages, right? So this is path attribute, IGP, that's fine. AS path, right? MP reachability NLRI, right? So that's what we are interested in, right? So this last update message, that is MP reachability NLRI. Let's see what type of route update it is, right? Next stop is 111, FE, SAFE, all that is there, common fields, right? Now let's check, hey, what type of NLRI or type 2, type 3, what, right, update? It's inclusive multicast route, means type 3 update, right? It's sending type 3 update, right? Okay, type 3 update. Let's see what are the information in that, right? So route type is type 3 update. So that's what the field, this is all common field, right? We all know. And route type is type 3. So that is what type 3, inclusive multicast route, length of that. So this is length of this type 3 update. And then field specific to type 3, right? What is that? Route distinguisher RD, that all we know what should be the RD, right? From where it comes. Ethernet tag ID, which is 0 in this case, right? Because this is again VLAN based. In VLAN aware bundle, it will be VLAN tag, it will add. Okay. So that Ethernet tag, right? It is 0 for this is wrong. 0 for VLAN hour and VNI for VLAN bundle service. Okay. So Ethernet tag will be 0 for VLAN base and aware, because we don't need to send that because we have VNI different, but VLAN bundle service, we will need to have Ethernet tag as non-zero. Okay. IP address, length of IP address, and VTAP IP address. So this is the length of the IP address, and this is VTAP who has initiated this type 3 route, right? So this is VTAP 1, which has loopback IP address as 1111. It has initiated that, hey, type 3 update, to say that, hey, I am part of this VLAN, right? This VLAN belongs to me. And basically this is extended to me, right? So based on that, now how do you know that this is part of which VLAN? Based on route target, right? So in route target, you have that, because for each VLAN in VLAN base, route target is separate, right? So based on 200, you will understand that this is VLAN 20, right? So VLAN 20, VTAP 1111 has VLAN 20 extended. So other VTAP will add based on this information that flood list for VLAN 20 and VTAP is 1111. So VTAP 2 and 3 will add that information into that flood list table. Again, encapsulation is VXLAN, right? And then there is one more field, if you see here, right? PMSI tunnel attribute. So which type of basically you are going to use, right? We have like hidden replication, right? Or multicast. So what type of you are going to, what type you are going to use? So this is ingress replication, means hidden replication. So we are saying that we are going to use hidden replication. And if you see here, we also tell that VNI is 200. So basically this is part of VLAN 20, which has mapped VNI 200, and tunnel ID is 1111. So based on this information, opposite VTAP will add that, hey, VLAN 20 flood list, one of the VTAP is 1111, right? VTAP 2, 3, 4, all will add this. Is it clear? Any question on any of this field if you have not understood?
So for VLAN bundle service, right? That Ethernet tag would be whatever the VNI is. Right?
Yes, VLAN. It will be VLAN.
Sorry.
Yes,
Yeah.
yes.
So in that case, will it import the route on the basis of Ethernet tag or community?
Yes. So let's say VLAN bundle, right? Which is second one, which we do not support. Arista does not support. Okay. Now, what was the difference in that compared to VLAN base, right? For multiple VLANs, right? Say VLAN 10, 20, 30, right? 10, 20, 30. It has same VLAN bundle has, okay? Same, sorry, it has same RDRT. It is same MACWAF, okay? So RD and RT is same, right? Say 1 colon 1. So are you able to identify at other end that this update message is for which VLAN based on RT value?
No. So that's when it comes. Okay, got it.
Not, right? We won't be, right? Because it can be VLAN 10, 20 or 30. Okay. Now another possibility we have is VNI. Okay. VNI, correct? So which is in case of VLAN aware bundle, we also have same situation that 10, 20, 30 will have same RDRT, but we have different VNI for each VLAN. So for VLAN 10, we have VNI 100. Okay. We send VNI 100. For 20, we have VNI 200. Okay. And for 30, we have VNI 300. So when you send this update, right, VLAN aware bundle, you have RDRT same. You won't be able to distinguish this update messages for which VLAN based on RDRT because it is same for all the VLAN. But you have VNI. You can check the VNI field and you can identify that, hey, this update is for this VLAN, right? Based on VNI. Is it correct? But the second option, right? VLAN bundle, the other one, VLAN bundle, right? Which we don't support. There, RDRT is same for all this VLAN 10, 20, 30, right? Same RDRT. VNI is also same. For all VLAN 10, 20, 30, only one VNI 100.
Mhm.
Now based on what you will identify, hey, this update is for which VLAN, right? So in that case, you need extra one more tag field, which is nothing but Ethernet tag, right? Where you have separate VLAN tag for each VLAN, right? So based on that, you will be able to identify, hey, this update belongs to which VLAN. So that's why that option we need to send Ethernet tag with that option, but other two option, because we have other ways to find out, we don't need to send.
Okay.
Is it clear?
Yes, yes.
Okay. Okay, so is there any question on this fields?
So is this route generated when a VLAN, like any port on a particular VLAN comes up?
Yeah, this is good question. And yeah, let me explain you or show you, right, when this route will be generated, correct? Yeah, this is good point. So now, see, this guy has nothing to do with, let me clear the MAC and app, right? So that you clear MAC address dynamic, right? Clear ARP. Clear ARP. Okay, show ARP. Show ARP. Clear ARP. .11.102. Okay, let's clear here also. Clear MAC address dynamic. Clear ARP 10.1.10.101. 11.102. Okay, now show MAC address table. It's nothing, right? That MAC is not learned, right? This is all static. Show ARP is also not there. We have not learned the local MAC and ARP, right? Correct. Now let's check the EVPN type 3 route, right? Show BGP EVPN route type. Which one?
Third one. IMET.
IMET, right? IMET. So IMET detail, correct? Do you see that is now generated? See, this IMET route is generated, right? There are many IMET routes, right? Correct? These are all type 3 routes. Okay. So even though your MAC is not locally learned or ARP is not learned, you generate type 3 route, right? Based on what? So let me show you. Show run interface VXLAN 1.
As soon as
So
we get a VLAN and VNI mapping, that it's generated.
yeah, not only that, but also as soon as we configured this, right? VLAN base or VLAN aware bundle service, right? Under BGP, and also this VXLAN configuration, right? Basically, this is also should also be there. Then only we'll know, right? This VLAN is extended or not under this VTAP, right? So as soon as we have this both configuration, right? VLAN 110 this and this, right? We will generate type 3 route.
Okay.
Okay. So it has nothing to do with MAC locally learned or not. As soon as you generate, basically configure, right? This and your EVPN neighborship comes up, you will start advertising type 3 route. Okay, clear?
Yeah.
Okay, so now let me, as we are already here, let me show you, right, how it will look like, right? So this is the one. See, IMET route for this is 254.3 is nothing but this VTAP. Show run interface loopback 1. I think it's loopback 1. Yes. So this is the VTAP IP address, right? VTAP or show run interface loop. Sorry, 1 minute. Show run interface VXLAN 1, right? Let's check which one is the loopback one only. Okay, so this is your VTAP IP address, right? 254.3, correct? So this is the information said. See, IMET route for this, right? 254.3, this current VTAP RD value is RD route distinguisher. So if you see field RD value, right, and then VTAP information, right, which VTAP is originating this, it is locally generated. Okay, route target is this, right? And then PMSI tunnel, right, ingress replication, the last field which we have seen this PMSI tunnel attribute, which is nothing but ingress replication, and tunnel ID is this 1111, who has initiated VTAP IP of the originator and VNI, right? So this all information is here, right? So PMSI tunnel, extended community route target, tunnel encapsulation VXLAN, VNI, right? What VNI this VLAN belongs to? VLANs, PMSI ingress replication, label 10110, right? So we have both VNI, and inside this also we have that information, and the tunnel ID or VTAP IP, who has generated this, right? So based on this and this VNI information, right, opposite VTAP will receive this route, right? It will receive this route and it will install this into its routing table, right? Show BGP VPN route type IMAT detail, right? 254.3, right? We are looking for 254.3. So see, it has received this route, right, with that VTAP 1 with this AS number. This is the VTAP originator, and this is the spine in between through which it has received. And based on this VNI and tunnel ID, right, it will create its show VXLAN flood VTAP, right? It will populate that, hey, for VLAN 110, because right now we have just received, we are discussing 110, this is the flood list. But because we have both the VLANs, right, it will send same route. If you see here, see, this is the route for which VLAN 110, right? VNI 110, right? But if you see next, right, why we are seeing two routes? Same, because one is received through spine 1 and another through spine 2. So that's why you have two paths available for this VTAP, received from spine 1 and spine 2. Okay. Now same VTAP IP 254.3. You are receiving for which VLAN? 10111. That is nothing but another VLAN, right? 111 VLAN. So you are receiving this route with IMET route for 110 VLAN and 111 VLAN, and that's why you are updating your flood list table that for 110 and 111, one flood list is this 254.3. Is it clear? Any question? Right.
Vishal, so this basically type 2, type 3 routes, right? This is my rib.
This
so
is
this is
yeah,
my
go ahead.
rib, right? So is there any way we can check how this is programmed in the hardware?
Oh yeah,
Like,
yeah. We can check. Show platform fab. I have to search. It's not on my show platform. Which platform? Oh yeah, this one. Hey, in this we
EOS.
won't be CUS, but yeah, definitely we have command show platform fab or
Okay.
scan, and then L3 route, and but basically we can check this.
Okay. Similarly for the flood list as well, right?
Yeah, it should be there. Yeah.
Okay.
But unlike Juniper, right, where we have seen a lot of issues with platform not programmed and software as, we don't see much, very rare. Basically, that bugs have already fixed, I would say. So that inconsistency, I have not seen much. Not seen, I would say, yeah.
Okay.
Okay.
Good to know.
Yeah. But yeah, definitely, we can check that, or we do check when, we see that, hey, this in software, it is there populated, but somehow we are not flooding that app request out, right, to other VTAPs, right? So in that case, we can check that hardware programming. Okay. Okay.
One
Yeah.
more question. So the bump traffic goes on the basis of flood list, right?
Yes.
So suppose if I want to troubleshoot if the ARP gets received on the other VTAP or not, can I put in ACL based on the outer or the inner headers, like for the counter?
Okay, so yeah, that's a good question. So see, problem here is, right, see, let's say you have put ACL here, right, towards spine, right? Show IP interface brief. Spine is connected to, let's say, Ethernet 1 and 2, right? Spine 1, 2. Now, if you count outer source IP and destination IP, right? How will you know that this is a ARP packet or any other packet? Because all the traffic will be encapsulated with this, with outer VTAP source IP and destination IP. So that will not help us, right? Basically, what we need is, we need to count the actual ARP packet, right? Inner header, right?
Yeah.
Which we won't be able to, because ACL will only look outer header, not the inner header, right? So that's the challenge we have, right, in troubleshooting. So generally, let's say, first of all, let's say ARP is not, basically ARP request, ARP is not learned, right, end to end. So first we can just check, show VXLAN, VTAP flood, right? That basically whether we have, 1 minute, VXLAN flood VTAP, right? First of all, we can check, hey, do we have all the necessary flood list populated, right? Then only we will replicate that, right, there. So that is one thing. If this is not populated properly, then you can check EVPN route 3 type, right? EVPN, whether type 3 route is received or not, right? I made detail that have you received the route for not it or not? If you have not received, go to that VTAP and check whether it is generating locally and sending out, right? So that is all troubleshooting related to route generated or not. If you have received, but still you are not installing in software, then again you have to troubleshoot on that perspective. So basically, first you have to make sure that locally you have flood list populated. Then what you can do is, basically ACL will not work, right? So you have to take mirror session, right, or capture, basically to check basically that this ARP request is sent out by this leaf or not, and whether it has received by this leaf 2A or not. So we are left with mirroring.
But even in the mirror, we can take TCP dump though, right? Because once it is generated, it should be like a normal R packet, and then it should go for encapsulation.
Yeah, I got your point, but generally that depends on, when we punt that packet to CPU, whether that, because this will happen at hardware, right? When flooding will happen at hardware, correct? So we won't be able to, we might not be able to see that packet in TCP dump, ARP request sent, right? Because it will be flooded at hardware level, chip level. It's not that CPU will flood, create multiple copies and send.
But then in case of receive, we should be able to see.
Yeah, so again, see, receiver, if it is app request is for this guy, right, gateway, then we might see. But if it is a data plane, right, app request has to come here and then decapsulate and flood it, right? It's not destination for which IP you are sending app request is not on leaf 2A, then it will be again taken
Data
care by
plane.
hardware.
Yeah. No,
Okay.
in case it is for like leaf 2A itself.
Then we should be able to see. Yes, then we should be able to see. Yes, but again, so see, both are routing VTAP. Then leaf 1A will never send route app request for this guy, right? 2A.
Yeah.
Yeah, but if leaf 1 is data L2 VTAP, then whatever request, tab request for gateway comes in, it will directly flood it, and 2A we should be able to see.
Okay.
Okay. Okay. Any other question? But yeah, all good question. And yeah, if any guys you are not following, please let us know. We can discuss again. Okay. So if we are good here, then let's move forward. I think we are already out of time. So let's quickly finish this, right? So yeah, this is the packet format. Okay. And this is what it looks like, right? So this is what we capture. We have seen, right? We have AFI, SAFI, and then all this information, right? That path at extended community, that is route target, right? Route target. So we will have route target. Where is it? Here, right? Route target. Yes, this route target, right? Then PMSI tunnel attribute, right? And where we will have ingress replication, correct? In Arista, you will see ingress replication because we don't support multicast. So you will always see ingress replication, right? And then this tunnel endpoint, right? That is the VTAP who has originated, and MPLS label is nothing but VNI in this case. Okay. As this is old packet capture snippet, that's why we are seeing some bogus value, but otherwise now it shows as proper value. Okay. So that's it. So this is how it happens, right? See, so VTAP 1, you configured VLAN 100, 200, VTAP 200, 200, 300, 200, right? This is your configuration. You have extended this 100, 200 across all 3 VTAPs, right? So now what it will do is it will send type 3 update. VTAP 1 will send as soon as you configured VXLAN and router BGP under that VLAN 100, 200, right? RDRT. It will send out type 3 update that, hey, I am VTAP 1. This is my IP address, VTAP 1 IP, and I am in VLAN 100. Same, I am in VLAN 200, right? It will send out that route type 3 update to all the VTAPs. What other VTAPs will do is they will populate based on type 3 update, they will populate their flood list, right? So VLAN 100, it has received a route update from this guy, right? Both has received update from this guy. So they will update that, hey, for VLAN 100 and 200, we have VTAP 1 in a flood list. Similarly, VTAP 2 also will send out this update, right? As soon as you configure that, right? So they will update that, hey, VTAP 2 1 is already updated, right? And VTAP 2 also has same VLAN 100, 200. So this is how they will update or populate their flood list based on type 3 routes, all the VTAPs, right? So this is how it works. Is it clear?
Yeah.
Okay. And that's it. So type 3 is, yeah, quite, there is nothing much. It's just the way we update the message. Let me just show you. So this is one update message, right? Which is IMET route, type 3 routes, right? There were other 3 update message, right? Let's quickly check what is that other, right? So this one is MP reachability NLRI, next hop, and this is for what, right? Let's check this update. This is again IMET update. So this is another IMET update by maybe 2222, right? So another VTAP is sending this update message, right? So this is also type 3 update message, type 3. What is this? This is also type 3, right? Because different VTAPs are sending that, right? Oh, sorry, this is update from only one, but for maybe it's for different VLANs, right? So this is also a type 3, and this first one is also an IMET update. Yes. Okay. So basically, yeah, all are IMET update sent by one VTAP, but for different VLANs, right? So you will have in one message, you will have multiple update messages clubbed. Okay. Any question? So basically, see, okay, yeah. Okay, sorry. Yeah. Any question? I'm just checking what is the VTEP IP 1111, right? So this is 111 as sent, this is 222 as sent, right? You have received basically because we have taken capture at both end, right? Then this is 111 next stop, and then last also is 222. So we learn 100 and 200, 111 and 222. So that's how it is for. Okay, any question? Okay, so I think in that case, we can stop here.